In Lesson 03, we're going to review your factoring techniques. In Lesson 02, we learned and reviewed your distributive property. Well, the factoring techniques are the reverse of the distributing property. So what we're going to do is we're going to factor. We're going to reverse the process of distributing and try to get back to our original terms that we had. So here's our two objectives. We want to rewrite polynomials in given standard form into factored form. So there's two vocabulary words here, standard form and factored form, that we need to be familiar with. And then we also want to review factoring techniques of polynomials. So some things here that we got to go through and hopefully try to communicate. I reviewed some of the basic techniques that you have used in Algebra 1 and through geometry. The factoring strategy or techniques, I kind of boiled them down into three of them. There's a step-by-step guide. Your first step should always be to factor out a greatest common factor if possible. Now, greatest common factor is known as your monomial factor. Is there something that goes into all of them, a monomial? And we'll demonstrate that in some examples coming up. So that's your first step. The second step should always be to check to see a resulting polynomial. If I do factor out a monomial, then I'm going to look at the new polynomial that has formed and check to see if it's a difference of two perfect squares, because they have their own unique factoring technique. If not, go to step number 3, which is factor it into two binomials. So it's kind of a 1-2 step, a 1-2 punch. What you do is you first factor out your monomials, which is a single factor, and once you do that, then you try to break it down into binomials or double monomial factors. So that's kind of an outline of the strategies that we're going to use. So we're going to go to our first type of problem here, and that is some polynomials can be factored using the distributive property. Now, the distributive property we just got done talking about is multiplying over addition or subtraction. They also use that terminology, the distributive property, to help you in factoring. So factoring to me is a little bit more specific about what we're trying to do. The distributive property is an overall concept or idea. You can either use it to multiply through with your distributive property, or you can use the distributive property to factor. So let's go and see how we can factor this first problem. It says 4a squared plus 8a. And factoring has its own special techniques here. And when I outlined those strategies, I said the first thing you should do is look for your greatest common factor, which is your monomial factor. Just go mono. Not so much momo, but I'd like to put mono. So what I'm going to do is I'm going to look at each of these factors, the 4a squared and the 8a, and I want to look at the numbers first. Is there anything that goes into 4 and 8? What is the greatest common factor of 4 and 8? And I recognize that to be 4, because 4 goes into 4 once and 4 goes into 8 twice. It has to go into each of the numbers evenly. But I don't want to give up on it, because there's also variable expressions there, a squared and a. When I have an a squared and an a, the greatest common factor in those two is just a. So what I'm searching for is my greatest common factor is this value right here, 4a. What is the biggest value I can divide into each of these terms that are sitting right here? 4a goes into 4a squared evenly, and 4a goes into 8a evenly. So now I know I'm going to factor out the 4a. So when I factor it out, then I pull it outside the parentheses, and what I'm left with is what goes inside the parentheses, and what I'm left with is what comes out after I divide. To me, what makes sense to me is when I use a distributive property, I'm multiplying. When I want to undo that, I want to reverse it. When I want to factor, I'm really dividing, since division is the reverse process of multiplication. So now what I'm going to do is I'm going to take this 4a squared, and I'm going to divide it by my 4a, and I'm going to take the 8a and divide it by 4a. So when I take the 4a divided by an a, the 4's cancel out, and an a will divide into a squared once, and I'll just have an a left inside my parenthesis. Then I have plus, and an 8 divided by 4 is a 2, and an a divided by a reduces to a quantity of 1. So this is my factored form. When you complete this, you can always check your work and say, well, what if I did this right, then if I redistribute, if I reverse it again and now I multiply, then I should come back to what I started with. So this factoring and distributing are a two-way street. You can get to one side by factoring, the other side by distributing. So if I do 4a times a, I get 4a squared. If I take 4a times 2, I get 8a. So there's our factoring process, and this is an example of factoring out a monomial. So That's always your first step. If you don't check, sometimes you're going to get burned by trying to go too fast into binomials. So what I'm going to do is I'm going to examine this 12x squared and the 4x. And I'm going to look at the numbers first. I got a 12 and a 4. What goes into 4 and 12 evenly? Well, 4 is the greatest common factor. 4 is the biggest number that divides into 4 and into 12 evenly. And then I've got an x squared and x, just like we had in the other one. I can factor out an x. That is the largest value that I can pull out. And I'm going to create my parentheses because we're going to factor, and factoring will always create your parentheses so that you can redistribute later. So if we divide both of these by, and remember, factoring is the reverse of distributing, which means we're going to divide whatever I put out here. I divide it by 4x, I divide this by 4x, it'll tell me what goes in these two spots. So 12 divided by 4 is 3, and an x squared divided by x is x. Then I got a positive 4 divided by positive 4, which is a positive 1, that's an equivalency of 1, and x divided by x is 1. The big mistake here is people will cancel them out and put nothing there, but there's 1. A 4x divided by 4x is 1. Any number divided by itself is equivalent to 1. I don't care what you put in there, 10 divided by 10, 12 divided by 12. If you put an a divided by a, they're all equivalent to 1. If you redistribute this, there shouldn't be any problem getting back. If you're checking your answers, that's going to be a 4 times 3, which is a 12x squared, and a 4x times a 1, which is 4x. Okay, so again, here's what we're doing. We're working with monomial factorizations. Our final factorization, it looks more complex. I've got an 8 and a 12, and I've got an a and a b squared and a b. So I'm looking for the number that goes into 8 and 12 evenly, or another way of looking at it is your greatest common factor. What is the largest common factor in 8 and 12? And the largest number that goes into both 4 or into 8 and 12 is 4. So I'm going to factor out 4. Then I'm going to target the a's. What is the greatest common factor between an a and an a? And that is an a. And I'm going to target the b squared and the b, or just the b's. And the greatest common factor between a b squared and a b is a b. That's the largest factor I can pull out. I'm going to set up my monomial on the outside, the binomial on the inside, and then you don't have to write this division out. I'm just trying to simplify it by saying, okay, now I'm going to divide this by 4ab, divide this by 4ab. It will tell me what goes in these two locations of my binomial. So the 4 goes into 8 twice. So 8 divided by 4 is 2. A divided by a is an equivalency of 1. And a b squared divided by b gives us the b remaining. Minus, or negative 12 divided by 4 is a negative. So that's a negative 3, because 4 goes into 12 3 times. The a divided by a is equivalency of 1, and a b divided by b is equivalency of 1, so it's just 3, just a negative 3 in that. That's it. If you go back and double check it, if you multiply these together, redistribute, you should get back to your 8a squared, 8ab squared minus 12ab. So those are monomial factorizations.